Imagine an invisible universe pulsing just beneath the surface of the reality we perceive every day. A space where familiar rules seem to dissolve, where particles appear and disappear, instantly entangle at unimaginable distances, and the very notion of time seems to waver. It is in this dimension, as concrete as it is mysterious, that 21st century science is writing its new epic. 2025 marks the centenary of one of humanity's most astonishing discoveries, quantum mechanics, but above all, it ushers in its boldest revolution. It is no longer the season of abstract formulas or paradoxes for a select few. Today, quantum physics comes down to earth, ready to shape technology, medicine, and even our understanding of existence. As the light of a new dawn refracts across the golden surfaces of the solar orbiter, the world's telescopes hold their breath. For the first time, humanity observes the sun's south pole, revealing plasma vortices and geometries never seen before. But what is truly surprising is not just the beauty of these images. Behind them lies proof that quantum technology is finally becoming tangible, capable of opening gateways in our perception of the universe. This is only one of many signs of an epochal change. In the world's most advanced laboratories, from Japan to Silicon Valley, quantum chips are beginning to perform calculations that no classical supercomputer can replicate. In China, a tiny optical processor has just set a new record, performing 100 parallel operations by simply harnessing the dance of light on nanostructured materials. It is as if quantum physics, after a century spent in insights and promises, has finally found its universal language: technology. What makes 2025 a unique year is not just the succession of discoveries, but their transversal nature. These are no longer phenomena confined to laboratories, but revolutions bursting into everyday life. Quantum sensors already allow us to measure the brain's magnetic fields with a precision unimaginable just a decade ago. Imagine observing, in real time, human neuronal activity as a thought or emotion develops. This level of detail could unlock unforeseen scenarios, from early diagnosis of neurological diseases to the possibility of understanding the mind's most intimate secrets. Quantum gravimetry devices now allow us to map variations in Earth's gravitational field with such sensitivity that they can detect even tiny underground cavities or changes in aquifers. These technologies, born from mathematical abstraction, are now becoming indispensable tools for medicine, geology, and environmental safety. But science knows no sharp boundaries, and the border between disciplines is becoming increasingly blurred. One of the most extraordinary developments in recent months is the convergence between artificial intelligence, advanced biotechnologies, and quantum tools. Thanks to the interplay between AI and CRISPR, the gene editing technology, researchers can now simulate millions of possible genetic combinations in a very short time, identifying favorable or risky mutations with unprecedented precision. This synergy is made possible by the enormous computational power of quantum processors, capable of exploring a multitude of solutions simultaneously, bypassing the limits of traditional computers. The prospect is not only curing hereditary diseases, but designing living organisms better suited to adapt to climate change, produce new materials, or even clean up polluted environments. In this ever-changing scenario, the discovery of a new organelle inside human cells, the so-called hemifusum, sheds light on a biological mystery that could have quantum implications. Scientists are questioning how some cellular functions evade classical laws and hypothesize that quantum processes may play a fundamental role even in the origin of consciousness or the transmission of genetic information. In short, life may be far more interconnected with the quantum world than we ever imagined. Basic research, often seen as an intellectual luxury, is becoming the secret engine of the global technological revolution. As governments and major companies invest billions in ever more powerful quantum computers, a new innovation race is taking shape in which pure knowledge becomes a strategic resource. By proclaiming 2025 the International Year of Quantum Science and Technology, the UN sends an unequivocal message. What's at stake is not just the future of technologies, but humanity's very position in the universe. The second quantum revolution is not simply an evolution of the previous one. It is a paradigm shift that promises to redefine our ability to observe, predict, and modify reality. But even if all this still seems like the domain of cutting-edge laboratories or articles in major scientific journals, the applications are beginning to touch our daily lives. The first navigation systems based on quantum interferometers already allow orientation with a precision that surpasses the best current GPS, enabling underground explorations or space missions with margins of error reduced to the bone. Solid-state batteries, developed with materials engineered at the atomic level thanks to quantum simulations, promise to revolutionize electric mobility, eliminating fire risks and exponentially increasing vehicle autonomy. In the energy sector, the first prototypes of quantum solar cells exploit superposition effects to capture a much larger fraction of the light spectrum, multiplying the efficiency of clean energy production. All this is only the beginning. If the first century of quantum mechanics was dominated by brilliant insights and apparent paradoxes, the new era opens up the concrete possibility of designing devices and materials never seen before, of intervening on the intimate structures of matter, of dialoguing with the invisible. The implications are almost dizzying. Yet what remains truly surprising is the speed with which this revolution is insinuating itself into the folds of our existence. If today we can measure the magnetic field of a single neuron, tomorrow we might be able to communicate directly with machines through the quantum fluctuations of our thoughts. And if today a chip just a few millimeters in size can process 100 parallel operations thanks to light, what boundaries will we be able to cross once we fully understand and master the deep logic of the quantum world? And yet, as science races ahead, the sense of wonder remains intact. Indeed, it grows. What does the quantum future hold? It is a question that is no longer rhetorical, but an invitation to cross the threshold of the possible, to question what we do not yet know, to let go of certainties and be swept away by the unknown. Behind every new discovery, there is always another question, a new door opening onto unexplored landscapes, onto universes waiting only to be explored. Looking forward along this accelerated trajectory, quantum science seems to call us to a kind of leap into the unknown, where yesterday's science fiction becomes tomorrow's technology. Think of how, just a few years ago, terms like entanglement, superposition, quantum bit seemed the arcane lexicon of an almost esoteric physics. Today, however, the same logic that governs subatomic particles is becoming the driving force behind disruptive applications. Banks experimenting with quantum cryptography to protect the most sensitive transactions. Biotech laboratories designing artificial proteins by simulating billions of configurations per second. Satellites communicating via non-locality, making transmitted information virtually inviolable. And these are no longer isolated experiments or conceptual proofs. The global quantum technology market is set to grow by tens of billions each year, while universities are training a new generation of scientists who move with ease among computer science, physics, biology, and engineering. Behind this acceleration, however, lies a deeper tension. Quantum mechanics forces us to rethink not just technologies, but the very idea of reality. Recent experiments have shown that choices made today can influence a particle's past, a kind of retrocausality that challenges our most ingrained intuition of cause and effect. Some researchers hypothesize that time itself, as we perceive it, is an emergent property from a network of quantum events. It's as if the universe, at a fundamental level, is an immense symphony of possibilities that become concrete only when observed. From this dizzying perspective, the technologies we are developing today could one day allow us to explore aspects of reality still unthinkable, from teleportation of information to controlled manipulation of states of consciousness. Meanwhile, research is expanding into once unthinkable fields. Some neuroscientists are beginning to hypothesize that the deepest mental processes, such as intuition, creativity, consciousness, may be linked to quantum effects in brain synapses. Pioneering studies suggest that the molecules responsible for photosynthesis in plants, or for the perception of smells in animals, exploit quantum states to optimize energy and information efficiency. And if life has indeed learned, over billions of years of evolution, to harness quantum mechanics, then its applications could be far more pervasive than we imagine. New self-repairing materials, artificial neural networks that learn through quantum fluctuations, biological computing systems that surpass the capabilities of the most powerful computers. The challenge, however, is not just about discovery but also control. To domesticate the power of the quantum world, tools of almost inconceivable precision are required. Lasers that generate pulses shorter than a billionth of a second. Detectors able to measure tiny variations in electromagnetic fields. Silicon chips engraved with atomic lithography techniques. It is a race against time and against the very limits of technology, where every advance opens up scenarios as promising as they are complex. Cybersecurity, for example, finds itself at a crossroads. On one hand, quantum computers could decipher in moments codes that today would take millions of years. On the other, quantum cryptography offers the possibility of unbreakable communications, based on the very laws of physics. In medicine, expectations are even more dizzying. Already, the first experiments in quantum imaging allow us to observe biological processes in real time, with a definition reaching down to single molecules. Technologies like quantum magnetic resonance promise earlier and more accurate diagnoses, while quantum computing accelerates drug research, allowing simulation of interactions between molecules and proteins with a precision unattainable by classical systems. Imagine a future in which medicine does not merely heal but anticipates illness, intervening on root causes before symptoms even appear. A revolution that could radically change our life expectations, opening the way to personalized and preventive medicine. But perhaps the boldest dream concerns our relationship with energy and the environment. Quantum simulations of new materials are accelerating the creation of ultra-capacious and stable batteries, of photovoltaic cells that mimic the perfection of natural photosynthetic processes, of catalysts able to transform carbon dioxide into renewable fuels. The fight against climate change and the energy crisis could find in quantum mechanics its decisive weapon. Innovative solutions, born from the imitation of nature but enhanced by the ability to manipulate matter at the atomic level. Yet, the true revolution does not end with technical applications. It is a revolution of awareness, of the very way we look at the world. If every particle in the universe is connected in a dance of probabilities and relationships, if reality is more a network of possibilities than a sequence of fixed events, then perhaps even our understanding of what it means to be human will have to change. We may have to rethink free will, the responsibility for our actions, the very idea of destiny. We are on the edge of an unexplored horizon, a territory where known laws give way to the possible. In this liminal space between certainty and mystery, quantum science does not offer us final answers, but invites us to ask deeper questions, to explore fearlessly the limits of knowledge. And perhaps, it is precisely in this endless quest that the true meaning of our adventure lies. Because every time we lift the veil on a new aspect of the universe, we discover ourselves part of an even greater enigma, called not only to understand, but to imagine what could be. If you have made it this far, it means you love curiosity as much as we do. If you enjoyed this journey, leave a like, write a comment and subscribe to the channel. It's the best way to support what we do. Your presence really makes a difference. Until the next exploration.